Having proven that the mean of the chi-square distribution is V, we are now going to find or to prove that the variance of the chi-square distribution is equals to 2V using the same this density function f of x of V. So to begin, I now have e of x square to be equals to the integral 0 to infinity of x square f of x dx. Okay, so I'm going to substitute the density function just the way I did it when I was trying to prove the mean in here. So I now have 0 to infinity, okay, x squared times the density function 1 over 2 power of v over 2 gamma of v over 2 times x to the power of v over 2 minus 1 times e to the power of negative x over 2 dx. So let t be equals to the power on e, that is x over 2, so that x be equals to 2t, and as usual differentiating x with respect to t, I will now have the x to be equals to 2 dt. Now we are going to substitute these new variables here. So this value together with the constant 1 over 2 power of v over 2 gamma of v over 2 integral 0 to infinity x v over 2 plus 1 e to the power of negative x over 2 dt. The x will now change according to the change in variables, so there is change of variables. So first the constant 1 over 2 to the power of v over 2 gamma of v over 2, okay, integral 0 to infinity x, which is 2t, power of v over 2 plus 1 power of v over 2 plus 1, okay, v over 2 plus 1, okay, then e power negative x over 2, and x over 2 is t, okay, and then dx, and my dx is 2 dt, so 2 dt. So this gives us the constant 1 over 2 power v over 2 gamma of v over 2, the integral 0 to infinity only 2 to the power of v over 2 plus 1, and then t also to the power of v over 2 plus 1, that is by splitting it, okay, then e to the power of negative t times 2 dt. So I will group my constant and bring them out. I have constant 2 with powers v over 2 plus 1, and then I have 2. So I am now going to write the constant out, starting with this 2 to the power of v over 2 plus 1, okay, then this 2 all over 2 to the power of v over 2 gamma of v over 2, then followed by integral 0 to infinity. Now I'm left with 2t power v over 2 plus 1, then e power negative t dt. Can you see? So I can now simplify the constant further. so as to have to reach cancellation stage. So beginning with 2, we have 2 to the power of v over 2 dot 2 to the power of 1. That is by splitting the first constant, then multiplying by 2 all over 2 to the power of v over 2 gamma of v over 2. So it is clear that this will cancel this, leaving us with 2 times 2. Okay, 2 times 2 over gamma of alpha, gamma of v over 2. So we have integral 0 to infinity t power v over 2 plus 1 e to the power of negative t dt. So clearly this result will now change to 4, that is 2 times 2 over gamma of v over 2. Okay, then the integral 0 to infinity of t power v over 2 plus 1 e to the power of negative t dt. Okay, but we know that the integral 0 to infinity of t power v over 2 plus 1 e to the power of negative t dt is defined as gamma of v over 2 plus 2. Since here I have v over 2 plus 1, therefore the gamma is properly been defined to be v over 2 plus 2. And the gamma function v over 2 plus 2 can be simplified as v over 2 minus 1 plus 2, okay, v over 2 minus 2 plus 2, okay, then gamma of v over 2 minus 2 plus 2, which can be simplified further as v over 2 plus 1, okay, then v over 2, then gamma of v over 2. Okay, having simplified the gamma function v over 2 plus 2 to v over 2 plus 1 v over 2 times gamma of v over 2. Therefore, to substitute, we now have 4 over gamma of v over 2 times v over 2 plus 1 v over 2 gamma of v over 2, which is the same thing as 4 times v over 2 plus 1 v over 2, then gamma of v over 2 all over gamma of v over 2, which is clear. Gamma of v over 2 cancel gamma of v over 2, leaving us with 4 into v over 2 plus 1, okay, v over 2, okay, so 2 here 1, 2 here 2, so we now have 2 into v over 2, okay, plus 1 v, okay. So when we multiply this together, we multiply it out, we now have 2v squared, okay, all over 2 plus 2v. So 2 cancel out 2, leaving us with v squared plus 2v. Therefore, conclusively, Ax squared is equals to V squared plus 2V. So now to find the variance, we recall that the variance is equals to, u of x squared minus u of x, so by substituting, here we have v squared plus 2v minus, this is the mean we have found, so this is v, but square, so we have to square it, so v square cancel v square, leaving us with 2v. Conclusively, the variance of chi-square distribution has been proved to be 2v.